All right, in this next section, we're going to look at integrals related to trig functions, um, because in the next section, we're going to be converting other integrals into things with trig functions. So we want to make sure we can integrate some stuff with trig functions first. Um, anyway, from Calc 1, we know a couple of derivatives. In fact, we know that the derivative of sine x is cosine x. So now in Calc 2, we know that the antiderivative of the cosine x is equal to sine x. And likewise, let's say the derivative of minus cosine x is the positive sine x. And so now we can write this down, that the integral of sine x dx is, the integral of sine x dx, yes, is minus cosine x. And I neglected to put a plus c there, and of course I need one here as well. Right, so sine and cosine are really nice. Each is essentially the derivative of the other, so each is essentially the integral of the other than that minus sign that pops in with the taking the derivative of the cosine, or hence taking the antiderivative of the sine. Anyway, the other derivative rules with trig functions were what? The derivative of the tangent of x is equal to the secant squared of x. And so the associated antiderivative rule would be that the integral of the secant squared of x is the tangent of x. Right? Now this isn't the integral of tangent, right? This was the derivative of tangent, which is now we're working backwards. So it's the integral of secant squared. Likewise, we knew that the derivative of the cotangent of x is minus the cosecant squared of x, and hence, working that backwards, the antiderivative, I'm going to move the minus sign to here and make that a plus sign, so that the antiderivative of the cosecant squared of x is minus the cotangent of x plus c, right? And there must be two others that we had. The derivative of the secant of x is the secant x tan x dx. No, just secant x tan x. And so arrow, right? So that turns into this rule that the integral of the secant x tan x dx is equal to the secant x plus a constant. And lastly, there must be one more. The derivative of the cosecant of x is minus the cosecant of x cotan of x. And so that turns into the antiderivative rule, or the integral rule, that the integral of the cosecant of x cotangent of x dx is minus the cosecant of x plus a constant. 6 trig functions, 6 derivatives, which now turn into 6 antiderivative rules. Notice that the first two actually are integrals of trig functions, where these other ones, the second one, third one, and so on, are integrals of combinations of trig functions. So not just secant of x, but secant squared or cosecant squared, or a product of secant and tangent. Okay. So I also want to get, how do I integrate the tangent function? How do I integrate the cotangent function, and so on? Actually, I think we've already seen the tangent function, but I will review it again here. That if you're looking at the integral of the tangent of x dx, that we think of that as the integral of sine x divided by cosine x. And we do a u substitution with u equal to the denominator there, so u equals cosine x. Du is, well, the derivative would be minus sine x dx. And this looks like an integral, so I'm missing a minus sign. Put it in, multiply by -1, multiply again by -1. The result is you've multiplied by 1. Right? So now I've got a u in the denominator, and the minus sine x dx is just du, so 1 times du. And this integrates, of course, to the natural log of the absolute value of u. Oops, but I lost the minus sign. That minus sign should be here. Minus the natural log of the absolute value of u plus a constant. So that's minus the natural log of the absolute value of the cosine x, which is perfectly legitimate to leave that way. However, usually you don't see it written that way. They take this minus sign and they write it as an exponent. So this would be the natural log of the cosine x, absolute value, raised to the minus 1 power plus c. And the raising to the minus 1 power is taking the reciprocal. The reciprocal of the cosine is the secant. So this is the natural log of the absolute value of the secant of x plus c. And that's generally the way you'll see it if you find it in tables or whatnot, that the integral of the tangent of x is the natural log of the absolute value of the secant of x plus a constant. Okay. Likewise, you could do the cotangent. The cotangent, the integral of the cotangent of x is dx. Cotangent of x is reciprocal of tangent, so that would be the cosine of x divided by the sine of x dx. And again, I'm going to do a u substitution with u equal to the denominator. In fact, this one's a little bit easier because we don't have to deal with the minus sign. Du is cosine x dx. So we end up with the integral of 1 over u du, and this is the natural log of the absolute value of u, but u is sine x plus a constant. So the integral of the cotangent is the natural log of the absolute value of the sine of x plus a constant. Okay, tangent and cotangent are done in a very similar way, right? I also want to look at the integral of the secant and the cosecant. These come up from time to time as we're working other problems. So let's make sure we know how to do those. And the integral of secant of x, I think, is one of those that I don't know how you'd ever think of this, but somewhere in history, somebody thought of it, and it was really clever, and they told their students about it, and those students became professors, and they told their students about it, or somebody wrote it down in a book, and now we know about it. It's pretty simple, but it's really bizarre. In fact, it's so bizarre that I could, as much as I didn't like doing these things when I was a student, this was one I could remember because it was just so off the wall. Anyway, with all that lead up, I'm going to multiply by 1. I'm going to multiply by 1 so that I don't change the value, I just change what it looks like. So I'm going to write a fraction here with the same numerator and denominator. And it's going to be secant x plus tan x divided by secant x plus tan x. Right? Just crazy. Why would anyone ever think of that? I don't know. I really don't know, but somebody did, and watch what happens here. So I'm multiplying fractions together, so I'm essentially multiplying this fraction times that fraction. And you multiply the numerators together, so the numerator becomes secant squared x plus secant x tangent x, right? There's a distributive property that gets it into both of those. And then the 1 is multiplied down here, so that's just secant x plus tan x. And I'm integrating that. And initially it's like, why? How the heck could that be any easier than this? Well, as it turns out, this is really nice. Let u equal the denominator. Secant x plus tan x. What's du? Well, the derivative of secant x is secant x tan x plus the derivative of tangent x, which is, that's an x, secant squared x. Look at the numerator. Secant squared x plus secant x tangent x, secant squared x plus secant, actually this should be all times dx. The numerator is exactly the du you need for u equal this denominator. So this becomes the integral, why is this doing this? Let's try this again. The integral of 1 over u du, which would be the natural log of the absolute value of u plus a constant, which is the natural log of the absolute value of, remember u was secant x plus tan x plus a constant. The integral of the secant of x dx is the natural log of the absolute value of secant x plus tangent x. I hate to say that's one you got to memorize, because you don't. You can always go back and derive it each time, and once you do this a couple of times, you begin to remember that, oh yeah, you got this secant x plus tangent x on the bottom, you got the du on the top. It's just a log of that crazy secant x plus tangent x. Anyway, there it is. That's the integral of secant x. I think it's just fascinating that somebody thought of that. Anyway, we can do the cosecant in a very similar fashion. So I'm going to do the integral of the cosecant x dx. and I'm going to do this by multiplying by 1. So I've got cosecant x times, we're going to do the cosecant x plus the cotangent x, cosecant x plus cotangent x on the bottom, cosecant x plus cotangent x on the top. So I'm multiplying by 1. I'm not changing the value. I'm definitely changing what it looks like. Okay. So distribute that top in there. So this is cosecant squared x plus cosecant x cotan x, and the denominator is still just cosecant x plus cotan x, and I haven't integrated yet, so let's still put that down. Again, just like the previous one, I'm going to do u substitution, where I let u equal the denominator here, cosecant x plus cotan x. Du then is, the derivative of cosecant x is minus cosecant x cotan x. Minus the derivative of cotangent x, well, plus the derivative of cotangent x, which is minus the cosecant squared x, this whole thing times dx. And I compare that to my numerator, and it is exactly negative the numerator. So this ends up being an integral of minus 1 over u du. So this is minus the natural log of the absolute value of u, but u is cosecant x plus cotan x plus c. Integral of the cosecant x dx. Okay. As we do the next section, we'll boil a lot of other integrals down into integrals related to trig functions. And so I wanted to make sure that we know how to integrate each of the basic trig functions. Cosecant, secant, tangent, sine and cosine, right?